what's up? In today's video, we will discuss about what analytics is. We'll have an in-depth overview of what this field, what is commonly known as data science or analytics, composed of. So, most of us have used the terms analysis, and we are quite familiar with this term, but not a lot of us know what exactly is analytics, right? So let me define this in very simple way. So analytics can be thought of as a part of this broader concept known as analysis. So basically, what it does is it uses tools and techniques in a scientific manner to derive certain insights. So, in very simple words, analytics can be thought of as a field of study which cuts across different disciplines. So, you need to have knowledge about mathematics, statistics, which are kind of backbone in this field. However, there's a huge dependency also on programming knowledge about databases, for example, the different sources from where you extract the data. So data sources can now be of various types. It could be a primary source or a secondary source. It could be a centralized, type of a system where you are storing the data, or it could be a decentralized system. It could be following an RDBMS-like structure, like structured query language. I am not sure if most of you are familiar with that. And there's also the NoSQL, counterparts as well. Computer science is also largely being involved, especially with the advancement of machine learning, artificial intelligence, and deep learning, which are heavily not only based on the statistical or mathematical models, but also draw a lot of inspiration from the programming aspects, which is often taught in the computer science in the academics, right? Now, depending on which field you are applying these analytical tools or techniques, you would also need to have a good grip on the domain or the sector. So it could be marketing, you could be working in a finance background, you could be in operations, whichever field it could be. Now, one question that's often used to arise in particular in my mind is that, is this an art or a science? Well, one might have a difference in opinion, but here's what my thought is. It's a combination of both, I feel. Now, why I say so? So basically, we need to derive results and insights of a business statement scientifically, whereas at the same time, we also need to use a single or maybe a combination of tools and techniques from our scientific toolbox. So this scientific toolbox consists of many different algorithms, many different methods, many different tools, and we could use n number of technologies to solve a business challenge. But why I think of this also as an art is because it hugely depends on the data scientist, you can say, or the analyst, you can say, who uses his judgment to figure out what is the best set of tools and technologies he should use to solve this particular business problem. Right. Now, a question that most people would think about is, why data science? All of a sudden, should I study data science? What is the overall prospects of this field? Now, as you can see from this following slide, the demand for data scientists has seen a almost 40% year on year increase in terms of job listings. And it has also led to a close to 67% increase in hiring. Right. The sad part, or probably the part where the opportunity lies for you, is that the supply is not adequate as per the demand. So there's a lot of demand for quality data professionals in today's world, but there are not enough people who have the required skill sets. Now, application of data science can be found in multiple fields, including consumer behavior, marketing, banking, finance, supply chain, all of these fields. It's heavily used in technology, in pharmacy, in financial institutions, in telecom, in airlines industry, in retail, e-commerce, manufacturing. It's widely used in the automobile sector, agriculture, as well as defense. Now, one of the you know common terms that often people get introduced to while working in this field is that of modeling. While we will be discussing about all of those details in subsequent videos that we come up with, what's important to understand at this point is that there are three very important, or I would say critical things that is really required for modeling. The first one being the theory. So you should have a good grip on the theory depending on the domain, the sector, or so it could be statistics or mathematics or computer science. You should have a good grip on the theory. The second one is you should also have information. We will cover these things in more details, but in short, in information, by information, what we are trying to say here is that you should have adequate amount of information in the form of data for you to be able to solve a business problem or a problem the community has in a scientific manner. And the third, and I think the most important also, is all the tools and technologies. So these three are the most essential tools for you to build a model. For example, if we were to determine the price of a product, how should somebody price their product in the market? There's now a lot of scientific measures that go on in the back end, based on which you see a price tag of, let's say, $99.99 when you go to purchase something in the store, right? Often, a lot of background theory is also required to come up with this price, but it's not always the theory which helps, because you need to also try to understand the buying patterns of different consumers across different stores, across different geographies. And these buying patterns also depend on who the customer is. So there are customers who are less price sensitive, there are customers who are more price sensitive. So there's this concept of elasticity of price, which is also very much required if you are trying to do a pricing analysis. So if you are still thinking whether data science is the right choice for you, I am pretty much confident that the future is really promising in terms of data science, and I think this is the right time for you to pick up the skills from a relevant source. Now, that being said, no one course or no one particular tutorial will ever be able to adequately fulfill your expectations of understanding everything about this field. So there's a lot of self research, self study, a committed uh, a routine that you need to follow, and there's no quick turnaround scheme that you can follow to master data science. So these are the basic and foundational steps to start off with, and I'm sure that you will benefit a lot from some of these introductory slides that we will be covering in this particular lecture. Uh, Now, following up on the discussion that we had in the previous slide, one important thing that you should also try to understand or be aware of is that we have entered the age of automation, right? Uh, it's quite evident that a lot of jobs which used to be done manually previously have been replaced by machines. So traditionally, men used to work for about, I'm talking about long back, right? Not just a few years ago, maybe long back. People used to work for about 16 hours a day, right? And the work hours that we have right now is around 8 hours a day. Although, unofficially people stretch beyond 8 hours, but that's the norm. So who knows? That to be more efficient, what it means today is that you try to automate tasks. any task that is repetitive is getting automated. And also, along with this automation, what is parallelly happening is that there's a huge load of data that is coming into the picture. And given the huge amount of data that's getting generated every second, in fact, every nanosecond, so storage has been a big area of research and focus. We had been traditionally introduced to the central processing unit, which we knew as the CPU, and then we have this GPU, and then we have also advanced to a stage where we have TPUs, which are much more faster processors, which can store massive amounts of data. There are cloud technologies which have gained a lot of prominence in these days. There's AWS from Microsoft, AWS from Amazon, Amazon Web Services, and there's Azure from Microsoft, and there's GCP, which is better known as Google Cloud Platform. These are the major and the big players in this cloud platform, where you do not have to focus much about around the architecture or the infrastructure of storing massive amounts of data, having all the security checks in place, and all of those things on premises. All you need to focus on is depend on keeping the data in the servers of these big giants, and all you need to take care about is how you are trying to build a model, how you are trying to build your algorithms, and how you are trying to do the scientific analysis, right? And also there's this prominence of serverless architectures, and we intend to cover more on this topic maybe in some other lectures, where there's a lot of prominence going on in serverless architecture. And virtual machines is one aspect of it, but there are more advanced systems that have come up, and we'll definitely plan to cover all of those in some other subsequent lectures. So, coming to the crux of what is analytics, I mean, we have introduced analytics in a very brief way, but it is something that also measures something. So the whole idea of analytics is to come up, what we said is to have a scientific approach or a scientific way of deriving insights or results from some information that we have gathered over a period of time. The most important thing over here is to understand that whatever we are trying to generate out of the study should be quantified in some way. There should be a measure, right? So analytics can be thought of as a measure of movement. Now there are KPIs that generally most businesses target. The KPIs could be of many sorts. It could be around performance metrics, it could be some diagnostic metrics where you have faced a certain business problem and you want to diagnose that, right? So what would be the right metrics to diagnose a certain problem? And there are again optimization metrics as well. And also it needs to be kept in mind that who are the consumers of analytics. So if you are a analyst, or if you're a data science professional working in a corporate company, in a banking or financial institution, and you have a business problem at hand, most often than not your client would be at a CXO level. He could be a CEO, he could be a chief marketing officer, he could be a CTO, a CFO or a CEO, whoever he is. So he would be the consumer of the analysis that you are doing. Depending on if you are doing a marketing project, mostly these are helpful for the CMOs who have to take enterprise level decisions in the marketing department. Similarly, if you're involved in the financial domain, then whatever analysis and results that you derive is often most useful for CFOs who are mostly in charge of the financial domains. There's a lot of interconnections between and across all of these departments, but again there are a lot of operational challenges that most teams comes across. So it's often a challenge to work in silos and So a lot of things goes on, but that's kind of the gist of who consumes the analytic solutions that you probably work on. This is a very basic illustration of a fruit vendor. So this fruit vendor used to come in our locality, and he used to come every day and sell fruits. Now one day he suddenly disappeared from the locality, and while I was passing on a certain day, I could see him in a different lane, and then I asked him why did he not come anymore to our lane. What he told me was surprising. He told that the customers in your lane, sir, haggle and bargain more. But here, in this lane, there are no such customers. Now, on asking him how he knew that the customers in this particular lane would not haggle much, what he answered me was surprising. He told me that in this particular lane, I see big cars. And because I see big cars, I had this assumption that there are people in this lane who would probably not haggle. So, what the fruit seller has done with his very basic and limited knowledge is some sort of an analytics. He definitely has not, used a lot of theory. He hasn't used a lot of techniques and tools, but essentially what he has done is he has segmented his market. He has segmented his market in such a way so that he knows who his target customer is and where he should spend more time and effort. So this is a classic example and a very simple example to understand, what's the power of information, right? Now, this is a quite important slide where we talk about the 5 P's of marketing, and this is a popular concept if you have come across. So, let's split it into. So first, let's talk about what are these 5 P's. The most important things of marketing are the product, the place, the price, the promotion, and the period, right? So, what is the product that you are selling, or what is the product that you are promoting, right? That is important to know. Where are you placing this product? Is it a store in the US? Is it a what kind of store format is it? Are you putting the product on an aisle, or are you putting it on the near the checkout lane, or in the center of your store? Where is the placement of the product? What is the price of the product is also a crucial determinant of your business KPIs. So that's one part. And promotion is, of course, especially in the context of Indian customers, I think they have a deal seeking behavior which is very inherent, and promotions are a huge area of focus, especially for Indian and most of the Asian countries. So that's to do with deals and offers, which is also very crucial information to process data. And what is the period? So in terms of data, the understanding the period is also very important. What is the time frame on which you have collected the information or the data? So talking more about data, we could have different sorts of data. When it comes to marketing, there could be a lot. In terms of financial data, there could be a lot of different other sources and types of data. Now, this is just a list for illustration, and there's much more. But I think this should give you a fair idea of what we mean by data and how time evolves, how tools, what exactly tools mean in this context. So we could have sales data, we could have data of the UPC or an item level data, right? So you go to a store, for example, you buy a loaf of bread, and a dozen of bananas, maybe a few packets of milk, and a box of butter, right? So these are the items that you have bought. And when the retailer has your data stored in their servers, they would have the data of what is the amount of goods that you have purchased, what are the goods that you have purchased, and what are the units of these goods you have purchased, right? So all of those data are stored in the transaction level data. demographic data is also often very, very useful in terms of analysis that we do. What exactly is demographic data, right? Now imagine that you are a retailer ABC, and you have customers coming in, right? And what you want to do is you want to give certain promotions on certain products that you have in your store. But uh, think for a moment, would you have a same promotion applied to all products in your store? Ideally not, maybe, right? So what is the most crucial information that you would need to understand if you should have differentiable product promotion or different other pricing offerings to different set of customers? So if there are a certain number of customers in your store who favor a certain category or a certain genre of products, you would ideally want to understand who those customers are, right? Who are your loyal customers? Who are customers who might switch to a different brand if there are other substitutes available? These all information are very crucial. So demographic data consists of the customer's age, the ethnicity, the race, his occupation, the level of income he has, you know how many kids he has, and lot of relevant information that could be really useful in marketing analytics projects. Transaction data is what we already spoke about. Promotional data is data for all the promotions, the deals or offers or events which has taken place over the history of time that we are tracking in the data. Events data could be if there are any particular promotions that has links with certain events. So there are a lot of these events in the US. For example, there's this famous event called Super Bowl, and a lot of promotions go on during this time. So if you see a sudden spike in the sales during the Super Bowl season, then you need to probably go and look whether there has been certain promotions that has been provided during this period. The holiday calendar is something that one should be aware of, be vigilant of, because often when looking at sales over a period of time, you would see peaks where the sales curve, you know, increases sharply around a specific time period. For example, if you are looking at a store whose product offering is mostly around seasonal products, and you would expect that in one particular season, maybe Christmas, the sales has spiked. So understanding the holiday calendar for every country, depending on which country's data you are looking at, is really important. Time is a very important dimension. To understand at what time your data has been generated or collected is really important. Your data could be generated at a daily level, a hourly level, a weekly level, a monthly, quarterly, half yearly, or an annual level, right? Tools. Now there are different tools and technologies, and these are just a few of them where you what is the mechanism by which you generate this data. So often when you go to a store, you have seen that at the POS counter, the point of sales, the checkout point, there's an executive who is helping you with your orders, and what he does is he scans a barcode from the cover of the product, and he scans it. So this is the most important tool or code which helps store all of these massive amounts of data that you work with. Often there are also sensors placed in different positions of a store to be able to track different customer movements, how much amount of time they have spent at one particular position, maybe in front of an aisle. So just imagine that you have an aisle in front of you where the aisles are loaded, the racks are loaded with chocolates, with heavy promotions, and you have been waiting for maybe 3 minutes over there. So there are these sensors who can track the amount of time that you are spending in front of an aisle. There are different marketing softwares also which help in this entire process of CRM, the customer relationship management. Um, Industry applications are many of analytics, so it's really not possible to, any list that we would create is going to be short. But here let's talk about four of the, four random industry applications which are widely used, and let's understand, go a bit into the more of the details about each of these applications and why they are useful. So the first is a segmentation analysis, right? Now, imagine that, again, let's take the case of a retailer. Uh, there are a lot of customers that go to retail stores. Now, each customer has his own behavior. Every customer is different from everyone else, each other, right? Now, imagine you being a retailer, would it be really feasible for you to understand and track the behavior of each and every customer? Not really. Such a micro level analysis of customers uh, might not be feasible and often might not lead to a significant improvement in the results that you are trying to seek. If your objective, for example, is to try out a certain promotion on a specific group of customers who are coming to your store, then often a very handy analysis that is performed is customer segmentation. What is done here is that customers of a similar group with a similar set of attributes or behaviors, maybe customers who are of the same income level or customers who are of the same ethnicity, who have maybe around 2 to 3 children at their household, who are of a specific age group, they are targeted differently than customers who belong to a different cluster of attributes. And how does this help the retailers? So, the first most important way it helps retailers is it helps them understand who are the target groups, who are those customers who the retailer should target, and this, in a way, brings in much more effectiveness and efficiency in terms of the promotion that is done. For example, you are a customer of a store and you are not ever interested in, buying a specific sort of product. Let's say, you do not want to indulge in the confectionery product group, and there are many such customers like you. Now, I, being a retailer, I am running a promotion which offers a 50% discount on all chocolate brands. But remember, there's a certain section of customers who do not absolutely consume chocolates at all. Now, how would it be if I spend a lot of marketing and advertising budget on targeting such customers like you for a promotion on chocolates? Certainly, the money could have been used in a better way elsewhere, right? So this is one of the examples where I could give you a flavor of why segmentation analysis could be important and how it could be useful for retailers. The other example that we could discuss about is MMX, or media mix, or often known as market mix modeling. What happens often is that the various advertisements or promotions that run on different channels that you see, it could be a television ad, it could be an ad on a magazine, it could be an ad that you see while crossing or while going to the airport. There's a big hoarding that you can see on the way. It could be a flyer that has arrived at your door. So there are these different medias, and these are called the different ways or tools of promoting your product or brand or company. Now, what is very important for a brand who is spending a lot of money, huge amounts of dollars on advertising through different channels, it's very important for them to understand how much amount of money to put in each of these tactics, whether they should advertise more on television, whether they should allocate more budget to television or to print, you know so this is a very critical decision, because that in a way helps in understanding what is the return on their investment. Another application is fraud analytics, where this is very much common in banking institutions, where often one needs to understand if a particular transaction that a customer has carried out is a fraud or a legitimate transaction. And if there's a chance that there's a high probability that the transaction a particular person has done is a fraud, then uh, the required measures needs to be taken to alert the customer that there has been a suspicious activity on your account, and there could be protective measures to immediately block the transaction and ensure that the customer's money is kept safe. So that's the huge application area of fraud analytics. Optimization is a very broad application area, and I think it cuts across different domains. And in each of these, in the back end, there's some kind of optimization that is going on. In very basic terms, this is I mean, it's a huge area in itself, but in very basic terms, optimization is trying to find out the best choice for you as a brand, a retailer, a manufacturer, or even as a human being, to find out the best choice given some set of constraints. There are certain resources that are available to you, and only with the available resources, what is the best that you can achieve. So you can imagine that you want to maybe minimize the cost of your company. So what you could do best given the so the optimization part is basically, we optimize things in our daily life as well. We have a certain amount of dollars or INR, whatever your currency is, you have in your pocket, and you go out to do shopping. You are able to buy products only worth the money you have in your pocket. You cannot buy much more than that unless you are taking a loan or you are taking the products on credit. Let's uh, rule out that assumption for now, but that's kind of the crux of optimization that we discovered or discussed in this previous slide. Now, one important thing in understanding all of these customer related behavior is what is the life cycle of a customer that you are looking at. uh, a typical retailer tracks the customer in four stages. The first stage is where the retailer, or the brand, in more general terms, is looking to acquire a customer. At this stage, the overall goal is to have a new customer get attracted to the product that you are offering. In this stage, often what happens, the kind of analysis that is often done is a customer segmentation. Maybe you have a bunch of customers. If your store is not a new one, if your store has been existing there out for some time, you have a bunch of customers. You have their profile information, who they are, what age group they belong to, what is their ethnicity, what is their income level. All of this information you have, and now you want to target a new customer, you want to acquire them. So customer segmentation is a very important technique that is often used. RFM analysis is also used. It's a kind of a very basic technique which is used to understand how recent your customer is, or how frequently your customer shops, or what is the amount of monetary transactions that your customer is doing. Depending on that, you would also try to engage the customer in a later stage to have them get attracted to more of your offers or more targeted promotions and offerings. So in this next stage, in the engage stage, it's very critical for you to also understand that what kind of promotions needs to be targeted towards a specific section of your customers. At the third stage that comes after engaging these customers is how to retain them. Now you are in a market position where you have, let's say, competition, and there's a chance that your customers might switch to different brands, switch to different products, and they might not be loyal anymore. So how do you understand who these customers are, who could probably churn, or who could likely switch to a different brand? So in this context, a lot of analytical tools and technologies that are used are understanding and determining the customer lifetime value, also in short CLTV. We often do survival analysis to understand how long a customer is likely to stay with this particular brand or company. And the fourth stage is growing the customer. So you have now a customer already with your brand. Now what you want to do is you want to introduce him or her to new products. You want to cross sell, or you want to upsell different products, so that you can make your customer more valuable. So understanding these four stages is extremely critical in the marketing world, or in any world, whether it's marketing, whether it's finance, whether it's operations. Understanding who your customer is and what are the different stages or the life cycle that your customer goes through is an extremely important thing to do a successful analytics project. um, this is very crucial in terms of the power of analytics. I think the most important things that are answered in analytics are summarized in terms of what we call as the four W's, right? The first one is what. So it helps us answer the following question: that what has happened. For example, sales has declined. When has it happened? So then sales has declined in maybe quarter 4 of 2019. So the time aspect is important also. The third question is, why has it happened? Now this is the starting point of the analysis that generally goes in each of these projects that we do. There could be a lot of different approaches in answering this why part. You could get your data from secondary sources. For example, the sales in quarter 4 2019 of company ABC has declined. Now this is possible due to a variety of reasons. Now you search the entire secondary space. You did a Google searches and all of those, some of those databases that are available on Google, and you probably found out the news that there has been some significant changes in the top management level, or maybe the CEO has stepped down, or maybe the company has entered into some unprofitable ventures which have been probably the cause of a decline in sales. So this is one approach where you look at things in a more research oriented way. You try to gather some insights and research findings from data that has already been published out there somewhere in the secondary space. The other alternative would be you have certain data, maybe, which uh, help you to find out the same insight, maybe in a more scientific manner. So the power of analytics comes in using data, the tools, the theory, and the techniques to dive deeper into this particular insight generation process, right? The reason why traditional BI tools might not be able to, help in this particular area is because they are very limited in terms of discovering patterns, or discovering patterns from data, or mining the data when the data reaches a massive scale. The other most important aspect of analytics is in understanding what to do next. So you have now understood what has happened, when has it happened, why has it happened, but you also need to prescribe something. You also need to uh, you know have a corrective plan. So that is where you need to come up with an action plan for the particular retailer, manufacturer, or whoever your client is, to guide and tell them that what should be their action plan now. So in the previous slide, what we saw is the four W's, which are very important in analytics. Let's now look at what are the broad categories of analytics. The first one is descriptive analytics, where you are trying to, you have a situation and you are trying to describe the situation through a lot of different metrics. And we'll talk about descriptive statistics in more detail in one of the subsequent lectures. The other type of analytics is diagnostic analysis, where you try to diagnose a certain problem that you have found out from the data or the information that you have gathered. Next is predictive analytics, where you are trying to predict a problem from beforehand, or you are trying to predict an occurrence of an event from beforehand. It might not always be a problem, it could be an opportunity as well. So, an example would be that, you know, so let's take this example of marketing mix, where you try to understand, how much budget you should allocate to each of the different media tactics to ensure that you have the best return on your investment, right? Now, in order to even arrive at that, you need to first understand what are the interrelationships between each of these different media tactics on which you spend. So, for example, on television, you generally spend for the advertisements, right, that you put on television, and a metric or a measure for advertisements is often known as GRPs or TRPs, right? And there's a certain amount that is charged for the number of GRPs or TRPs. So there's a relationship between the amount of spending that you are incurring on a particular media tactic, be it television, be it radio, be it magazine, and the amount of sales that gets generated. Now, once you understand this relationship between all of these variables, it's now easy to find out what could be the value of sales. It could be dollars, it could be in terms of volume, unit sales, any of the sales that you are trying to predict. It's important for you to understand that, this understanding of the relationship among these variables would help us to know and predict what could be the sales value in a future time point. So this field or this category of analytics falls under what we call as predictive analytics. And the last one is called prescriptive analytics, where the idea is similar to what we discussed in the last slide, where we said that, we now understood the problem, we diagnosed the problem, we try to predict if a similar occurrence happens in a future time point. But what's most important now is we want to prescribe a solution. So, if we see an imminent danger or a problem in terms of business, we need to have a set of corrective measures, or we have to set a corrective action plan so that the same does not get repeated in the future. So, for example, again, taking the example of the marketing budget on different media tactics. Now, imagine that you have been spending a lot of money on advertisement of your particular favorite brand product through television advertisements. Now, the reason for spending so much is because you expect that by advertising more and spending more on television, that would generate incremental revenue for your brand. However, what you are seeing is that, it's not generating as much as you would have expected it to. So you now want to dig deeper and understand what could be the really problem area. And one of the situations could be that is popularly known as the concept of saturation. Now, we will talk about this if we are talking about the specific project in details, but to give you a brief idea about saturation at this point and in this context, what it means is that if you are trying to spend some amount of money on a continuous basis on television advertisement over a period of time, it might not necessarily translate into greater sales. So if you imagine having two axis diagram, x and y, and on x you have the amount of spend on the grps, and on y axis you have the sales. The curve for a specific, if you're trying to incrementally increase your spend, it might not increase your sales proportionately. So the line or the graph would not be a straight line, or would not continuously be increasing in the positive direction. It would often flatten after a certain point, and that is where this concept of saturation comes into play, where that there has been enough of advertisement of this particular product over this given time period, and any extra advertisement that you are doing is really not helping in terms of getting more revenues. So that is the point where you now know that, okay, next year I should not put the same x amount of dollars on television advertisement. Maybe I should put some amount which is lesser than x, and maybe reallocate some of this budget to a different tactic where the saturation has yet not reached. An important distinction which needs to be made in this context is the difference between mathematics and statistics. A lot of folks get confused at the starting point, trying to understand if there's a subject like mathematics, and if we have a background in mathematics, why do we need to study statistics? Because it's looking like the same maths that we all do, right? Now, the most important distinction between the two is in terms of whatever we would be using and seeing in the context of analytics, is that mathematics mostly deals with deterministic relationships which are of the exact form. So it's like this following function where y equal to function of x. Imagine y being sales and x denoting any factor or any variable that could influence sales. So what we are essentially trying to say from this relationship is that sales is a function of so let's say the sales of ice cream in a particular outlet is dependent on what are the factors that you could think of. One could be the temperature, which is part of the weather. It could be the location where your store is set up, right? So let's say you have these two factors which is represented by x. Now this function is described by a particular relationship or a particular formula. What mathematics teaches us is mostly that this formula holds true and is an exact form. So if y equal to a plus bx is the formula for y is equal to function of x, then if you know x, then you know the value of y. So just for example, if in y equal to a plus bx, we know that if we are trying to solve a simultaneous equation system, for example, you have two equations and you are trying to solve for two parameters from these two equations, then you would be able to solve this problem, and you would eventually get to know what is the value of x, what is the value of y for a given value of x, for example. Now what statistics tells us is that there's a huge role of uncertainty in the real world. So statistics deals with inexact relationships where they slightly modify the above function and describes this function as y equal to function of x and u, where u is this additional term which addresses the concept of uncertainty. So what this u denotes is basically, for example, even if I knew what the weather is, if I knew where I placed my store, even if I knew who are my customers, I would not ever be able to exactly, correctly predict the sales. So no matter how much of variables, how much of data I would have, I would never be able to be exactly accurate in my measurement of the value of y. And the main reason why that is being said is because there is an uncertainty in the real world. What we can arrive at is a close enough approximation to the real value, but we might not be able to reach the exact value that we are looking for. So this U or uncertainty captures in essence a lot of omitted variables. Now what we mean by omitted variables is there could be a lot of factors which we are not accounting for. Either there might not be enough data sources to capture them, it might not be feasible to capture a particular metric or a particular variable. For example, a lot of variables are qualitative in nature, and it often depends on the discretion of the user how exactly he defines this particular variable in a quantitative way, right? So there's some kind of bias that gets introduced into the system, and that's kind of being accounted for in this term called U. Often there's also this concept of measurement error where uh, we assume that there could be a certain amount of error in measuring each of the variables. Some of these errors could be because the scale that we are measuring with might be faulty, or there has been a certain glitch in measuring the precision of a particular measurement. So there could be a lot of factors which could lead to measurement error, and these errors could lead to deviations of the value of y that we predict from what it is in actual. And the most important uh, aspect that the term U tries to capture is the inherent randomness in human behavior. So in economics, there's this concept of rational expectations and adaptive expectations, which mostly talk about how a particular individual should ideally respond to a given stimulus or to a given treatment. So, for example, if you go to a store and you see a particular promotion going on, your rational choice would often maybe to purchase the product, assuming that you have the money or the purchasing power to buy the product. But there is often a inherent randomness in human behavior that is very hard to predict, and this is where U comes in very handy. And this is the uncertainty that statistics or statistical models that we would be extensively talking about deals with. I think by now we have a good understanding of why we need analytics and what is the power of analytics. I want to provide you with an alternative perspective, which is the big data perspective of the need for analytics also. Now, I'm sure most of you are aware that the data size has increased tremendously over the years. What usually used to be, long back, just one, maybe a small piece of data has now emerged into a uh, amount of data, which is very hard to store in a small database. Looking at the measurement of bytes and bits and all of these things, that what we can see is that we were aware of kilobytes. 1 kilobyte used to be around 1000 bytes, where 1 megabyte is almost around 1000 kilobytes. 1 GB is approximately around 1000 megabytes. 1 terabyte is again around 1000 gigabytes. Now we have entered the world where we are now dealing with petabytes, which are again 1000 terabytes make up 1 petabyte, and there's this 1 zettabyte which is being made up of 1000 petabytes. Till 2010, around 1200 exabytes of data has been created by human. By 2020, there has been a 40,900 and more growth, exponential growth in this uh, data. So the most prevalent question that would come to anybody's mind is, If data is getting generated in such huge volumes, one aspect is the storage of it, and the other aspect is, given that you have the storage and you have the speed taken care of by large tech companies, what will you do with so much amounts of data? Isn't that a really powerful thing to have? You can derive massive amounts of crucial information from the massive chunks of data. So that is the power of analytics, and big data is now everywhere. Imagine if you are looking at, Twitter or any of the social media, right? Look at the technological evolution. Telephones have been replaced by smartphones. We now have unlimited storage on the cloud. There's internet of things, there's social media. All the network of tools are now interconnected and they communicate with each other over the cloud, be it appliances, be it sensors, be it self-driving cars with fit-in sensors. All of these are measured in terms of zettabytes, which amount to almost trillions of, like 1 trillion of gigabyte makes up around 1 zettabyte. And I think IoT is almost expected to about, if I remember clearly, I think it's about to generate around 500 zettabytes of data. Traditional BI tools can definitely not deal with this much amount of data. In terms of social media, Instagram data, the speed of that, the frequency of data getting generated is around, I think, more than 1.7 million pictures per minute, whereas for Twitter it's around 350,000 tweets per minute. And there's YouTube, there's Facebook. Transactions have mostly shifted to online. There's this prevalence of e-commerce stores right now, right? And there's no doubt, absolutely, that we could derive and extract a lot of useful insights from such massive amounts of data, which could help us in turn into deriving strategic business decisions, or it could benefit our community, it could benefit individuals in a much better way. And in the Indian market, I think most of you would be aware of Ola or Uber, which are, I think, the most prominent players in this automobile field right now. And there's this technology and tools that they have introduced into the market. Their super easy navigation, their absolute flexibility with their tools and technologies gives customers a unique and seamless experience. So this is how there's a massive amount of business opportunities that's getting created through the form of technology and innovation. So that's all we had to discuss for today. Hope you learned something new, and don't forget to click on that bell icon and the subscribe button to stay updated about our new classes or sessions. Stay tuned. We'll catch up soon.